try to record. Okay, there it is. Sophia has started it. Well, welcome everybody. Let's get this going. Good afternoon. Welcome to the RISE presentation on dimensioning and annotations led by the Charlotte office. My name is Salvador Frieri. I'm one of the RISE coordinators for this year's series, along with Dana Wamberg, Charlotte Miller, and Gonzalo Gomez. For anyone that's new in the region, we want to highlight that RISE is a learning series composed of monthly presentations on different topics relevant to our project work and to our licensure. This year, we've learned about specifications, writing, demountable partitions, furniture, power and communications, mass timber, designing for extreme conditions, and we've also learned about inclusive design. In the next couple of months, we're going to be learning about exit discharge and model and beam coordination. And today, we are going to be talking about dimensioning and annotations, as I mentioned before, led by the Charlotte office. Please note that on your screen, you have the QR code to receive your CEU, and we will post on the chat also a link if you prefer to sign up using the link to get your CEU credit. Also, any questions, please feel free to put them in the chat. This presentation is going to take approximately 40 to 45 minutes, and after that, we're going to have 10 to 15 minutes for Q&A. So with that, let's get this show on the road. Sean?
Thanks, Salvador. Thank you, and welcome to this month's RISE presentation on dimensioning and annotation. My name is Sean Harmon. I've been an architect for about 18 years, and I've been a project architect with Gensler for the past 5 years here in the Charlotte office, where my primary focus has been on design technology and design realization.
Hi, everybody. My name is Brad Bello. I have about 24 years of architectural experience, including about 15 with Gensler. I started out in the DC office, and in about 2015, I transferred here to the Charlotte office.
And as I said before, I'm Salvador Frieri. I've been doing this now for 26 years, and if all goes well, I should be getting a beautiful vest in November because it will mark my 5th year with Gensler. First, I was with the Miami office, and since last year here in Charlotte.
All right. With our objectives today, we hope that participants will learn why proper dimensioning and annotation is important. Participants will learn about dimensioning and annotation methodologies. We hope to provide an understanding of when and to what extent dimensions are necessary. And we will give an overview of Revit tools and support community. As always, there's a AIA HSW credit. And as Salvador had mentioned, we have the QR code and we will be posting in the chat the link. Here at Gensler, we strive for a holistic process between disciplines that we call design synergy. And today, with today's presentation topics, we will focus on the content within on the how we bring the vision to life under design realization. With that, we are focusing on the documentation framework and these 5 topics: dimensioning methodology, annotation, scheduling and tagging, door types and schedules, and partition systems. For that, we'd like to get into some construction myths and construction facts. So some things with construction myths that we think we know, we think contractors build to the dimensions shown on the drawings. We also think that we conduct field verification of existing conditions, so what we have shown must be right. But there's also construction facts, and what we really know that contractors make mistakes building things, architects and designers make mistakes measuring things, and contractors and architects and designers make a lot less mistakes when they are not confused by things on the drawings. And it is worth note here, the pictures that are shown on the screen are not Gensler projects. And with that, I'd like to kick it over to Salvador for dimensioning methodologies.
Thank you. So let's talk about dimensioning methodologies for a few minutes. So as you'll hear us say throughout this presentation, this has been put together based on our documentation framework. This document basically provides for us the standards on how and why we should dimension in a particular way. So why do we need the standards? First of all, to save money and time. Time is money. We if we have set standards, we can worry more about what we're doing and less about how we're doing it. That's always huge. And also to facilitate inter-office collaboration. We are a one firm, remember? So it is very important for if I'm collaborating with somebody in one of the offices in Texas or one of the offices in the region, which happens every single day, then if we're all used to dimensioning the same way, it's going to make that collaboration much easier. So when dimensioning, we must always remember that the task at hand is to communicate the location and size of the different elements that are going to be built, and that we should do it following a hierarchy. So for example, if we are dimensioning a ground up project, first we start with the layout of the building on the site, and then we move on to laying out the exterior walls, then the grid relative to the exterior walls. We lay out major interior walls and other main features relative to the exterior walls and the grid. We lay out structural elements, column relative to the grid. So as you can see, there's a specific process in which we should be dimensioning. Then we locate doors, windows, and other elements relative to walls in the grid. Always remember that all dimension strings should tie to grid lines. So our documentation framework provides guidelines for each type of drawing, whether it's a site plan, a floor plan, or a roof plan. In the framework, we can see what's the recommended scale, what dimensions need to be provided, what we need to make sure that we are coordinating, and what special indications we should be conveying. We should always remind ourselves to model accurately instead of rounding dimensions. That's a big no-no. Next, please, Sean. So as mentioned in the previous page, the documentation framework also provides guidelines for elevations and large plans, section and plan details, door and window details, interior construction details, amongst others. When placing a dimension on a drawing, we should always ask ourselves, is this dimension giving clear direction to the contractor to determine how to lay out these items? So you can see in these rectangles what the documentation framework says about specific items. And it reminds us that when we're designing a space, not just when we're dimensioning it, but when we're designing the space, we should avoid creating spaces that will require a dimension that's going to be tighter than an eighth of an inch or maybe even a quarter of an inch. If we can make it round numbers, why not do it that way? Next, please. So here in the Charlotte office, we pride ourselves in having a strong technical team, but we all have different backgrounds and are all used to dimensioning in different ways. Even though the documentation framework provides clear direction on some aspects, others can be interpreted in different ways. What you see in the photo actually happened, where Jeremy Fisher and I held a battle where we both presented to the office our dimension method and why it was the correct one. We each felt our method followed the documentation framework. We even brought a general contractor as one of the match referees. Interestingly, there was no clear winner. The conclusion of the match was that depending on the design goals, one method can be better than the other. That's always something to keep in mind. Next, please. So the documentation framework also provides good and bad dimensioning examples to illustrate that we should always organize the dimensions clearly, maintaining consistent reference points, not repeating dimensions unnecessarily, and where to prioritize. We should always remember that dimensioning is one of the prime methods of communication on a project, and it's the key to producing successful construction documents. If done well, it can help the construction process run more smoothly and efficiently, but if done poorly, it can be one of the leading causes for confusion and RFIs. I mean, we measure the success of our CD set through how many RFIs did we get sometimes. To be able to provide appropriate dimensions on construction documents, it is important to try to put ourselves in the situation of the contractor and to keep that information in mind as the drawings are prepared all the time. Next, please. So the documentation framework also reminds us to not over-dimension, to pay attention to the hierarchy of the dimensions and to model correctly, avoiding the need for manually editing or rounding dimensions. We should remember that the goal is to give clear, concise direction to the contractor. Next, please. So we brought in a couple of examples, from three different projects. This is the first one is a ground up project, and as you can see, it is a large floor plan. So the first thing we did is we divided it into 6 zones, but in the general construction plan, we are providing the dimensions for the grid lines. Those are the only dimensions that we're providing here. Then in the next page, please, you can see one of these enlarged sections of the floor plan. The lines are the match points, and then we've highlighted the dimensions that are referencing the grid lines. So as you can see, a lot of the dimensions reference the grid lines. So this document was following the hierarchy that we discussed before. In the next example, we have a project where the scope was for an interior fit out. So it was an existing building. We do a lot of this work, of course. And what we want to highlight here are two things. First of all the enlarged plans that we had to call out because we felt that at this scale, an eighth of the scale, the information provided was going to be confusing if we tried to fit all of the dimensions and tags in those spaces. So as you can see, there's a lot of callouts in this plan. And within those callouts, there's only sheet notes. There's not much else, and that's the way it should be. If you are doing a call out, then you should put all of the relevant information in that enlarged plan. You should try to keep the information here only to the spaces that have not been called out. In yellow, we want to highlight all the alignments that we're showing and dimensions that have no numbers that are equals. So that is very important because it shows what the design intent is and provides the GC clear direction on where to begin laying out the walls. In the next example, we have a space plan that had a diagonal, and as such, we're providing a starting point, and you can see it shown in a circle highlighted in green at the lower left part of that of that rectangle that has been rotated a little bit. We even went as far as showing the dimensions for that starting point in red to give them priority and to be very clear. And then you can see the dimension strings highlighted in yellow. They all start from that starting point, of course. And with that, we're going to talk a little bit about annotations. Brad?
Thanks, Salvador. Appreciate it. From the mentioning, we will dive into annotations. So what are drawing annotations? Well, drawing annotations convey critical information about the project that graphic information cannot. They are the link between the drawing's quantitative information and the specification's qualitative information. So drawings generally describe location. Tools like dimensioning, as earlier described, assist in explaining where things are located within the project. Size and form, defining the shape of the elements and assemblies that are to be created. Dimensioning and notations help convey this information. Quantity, which is pretty straightforward, graphically or noting quantities, ensure more accurate construction through the drawings. And relationships between assemblies, whether between materials or full assemblies. The drawings clarify how the fundamental building blocks are blended together into a cohesive work of architecture and interior design, from the placement onto the site down to the final finished application. Other generic information is also included, basically other miscellaneous notations that help clarify the drawings. I need to get my camera on. Hi, okay. In contrast, Specifications or the project manual describe the qualitative information. Products and materials, essentially the item being specified, anything from an exterior wall type down to a hardware lever handle, anything that's in the design would be noted in the specifications. Performance requirements, ensuring the product meets the required standards. This can be structural, architectural, environmental, just to name a few. Physical properties, also defining in detail the characteristics of the products to be selected. Workmanship standards, establishing guidelines for how products are created and processed. And administrative procedures, verifying compliance with applicable standards as defined by governing bodies or jurisdictions. This is why we submit both drawings as well as specifications together to help describe as clearly as possible our architectural design to be constructed. For our purposes here, we'll focus on the annotations in the drawings and leave specifications for another presentation. Annotations and drawings come into fundamental categories, written and graphic, as shown on the screen. We'll continue our presentation with written annotations first. Written annotations are generally categorized by the following: text notes, keynotes, project information notes, general notes, and schedules. Starting with text notes. The text notes are elements on a drawing that are used to provide information to identify the drawing's graphic representations and/or instructions concerning the use of the drawing or execution requirements for the work that are not otherwise specified. It's quite a run-on sentence. They're usually keynotes or notes directly on the drawing. An example of a text note can be seen on the detail on the screen that shows things such as existing slab or centerline transition strip and door. These help provide clear information to complement a particular drawing. Keynotes are used to identify graphic representations of project elements and directly refer them to the specifications. Keynotes identify general section and material references from the specification section. So looking at the drawing example once again on the screen, the Gensler keynote system is applied to provide simple, clear, and consistent information meant to bridge the drawings over to the specifications. So if you are not familiar with using the Gensler keynote command in Revit, then you can check out the Gensler No article that's located in our database. But to summarize and refresh everyone's knowledge, the Gensler keynote system can automatically tag components within a Revit detail. All you have to do is select the keynote command, then hover over the design material, then locate that tag to the desired spot. Note, however, that in order for this to work properly, you must be inserting components that already have this database information built in. So make sure when creating new details that you are importing components from the avail channel. Do your best not to sketch out shapes with detail lines if possible. Gensler has invested a great deal of time over the years to develop a robust database of components to make this step easier for the rest of us. The keynote system, when used properly, will populate a number in text, like the example shown. In this example, the first 6 digits represent the specification section, in this case 092900, and tells the reader exactly which spec section to go to. The next 3 digits after the period is usually a letter and 2 numbers, in this case .A00, and this is an internal identifier, and it helps ensure each description in the database is unique and nothing more. This does not relate to anything within the spec section. Finally, the text, in this case gypsum board, provides a brief description of the material and the detail. Further information on the quality of this material can be found in the specification section that it directs you to. Continuing on this page, we have project information notes, and these notes are usually located somewhere on the front end sheets. It's like a brief summary of the project, describing the general scope of work, governing codes like IBC or specific amendments or NFPA, location of the project, like using location maps, project teams, like the consultants, developers, and the owner, as well as other general information. General notes, these are used to convey general information about the specific drawing sheet or series of drawing sheets that they are located on. Here at Gensler, we typically note this list in alphabetical order, A, B, C, D, etc. So the list on the screen is a good example of general notes. Note E talks about maintaining a 4-inch clearance between the edge of the door frames and the intersecting partition. This is an easier, clearer way to describe the specific rule applying to the drawing, as opposed to providing dimension at each and every single door that this may apply to. Finally, we have schedules. And a schedule is a collection of information which can be used in various formats to cover a wide range of both general and project-specific information. When using Revit, and depending on the type of schedule, the content can either be input manually or automatically generated based on information attached to the element properties, project information, or other annotations used in the drawings. We'll discuss some of these examples a little bit more in the presentation. Let's see here. So going into graphic annotations. Graphic annotations are generally categorized by the following: sheet notes, legends and symbols, and tags. Sheet notes are numeric symbols used to identify, inform, and provide direction about the drawing's graphic representations, usually without direct reference to the specs. These notes are created during the development of the construction documents, and just as described, provide a little more clarity and direction regarding where graphic representations cannot. Gensler developed the Sheet Note Manager in Revit, which helps manage these sheet notes into a single database per project. This program helps prevent accidental cross-referencing between notes and numbers. The Sheet Note Manager, as some of you may know, can be a little bit fussy at times, but if the project team is aware of the application from the beginning of the project, then the Sheet Note Manager can work very much for you more than against you. Now, often when a conflict occurs, it's usually because a sheet note accidentally received multiple notes to it, or multiple sheet note tables are getting applied to a single sheet. So these are a couple of examples where the Sheet Note Manager will help identify some of those conflicts. Be sure to coordinate with your team, though, at the beginning of the project as well as during the project when using the Sheet Note Manager. The middle table, talking about legends. Legends define graphic symbols that are used to identify elements and materials shown on the drawings and provide additional information about them. An example shown on the screen organizes and explains the basic construction symbols for a construction plan. So in this case, the legend is noting the graphic representations for wall types to make it clear, as well as a line style signifying any fire ratings within these walls. The third diagram is a good example of tags and symbols. Tags provide additional information about elements and materials shown on the drawings and provide additional information about them. This particular legend shows tags for a reflected ceiling plan. Some of these tags, when used, will automatically input information like the height of the finished ceiling or material assembly of that same ceiling. Also included are symbols, which include simple, more diagrammatic way to show elements within a project. So like the MS motion sensor symbol here is shown, and it may not be an actual component modeled in the ceiling, but is rather a graphic representation of a material element. So let's go ahead and move on to scheduling and tagging for finishes. So there's definitely one example here for we talk about scheduling. As design decisions are made, finishes are selected, reselected, revised, and finalized. So how do we typically note these in the drawings? Starting on the micro level, we have the finished code. Gensler has a standardized system of unique identifiers for the finishes in the project. The standard format for finished codes is 2 letters followed by 2 numbers with no space in between. To view the firm-wide standards for these 2-letter codes, please refer to the firm-wide finished code list. The numbering portion has a little bit more flexibility. You can group the numbers based on location or type within a material, or just start at number 01. It's up to each team to determine the clearest and most logical way to organize. Whether you decide with how you want to set your finished codes, please do so as a team and as early in the project as possible to prevent confusion or lost time due to code reorganizing. Placing tags, placing the finished tags on the drawings. Another decision to be made near the beginning of the project is how model finishes and how we actually model finishes in the Revit project. and how the finish tags will operate within Revit. So there are really usually two main schools of method in terms of finish tagging in a Revit model, particularly with the wall finishes. The first and more old school way involves inserting a pre-coded tag into the drawing and manually indicating where this finish is located. These tags do not extract any information from the component itself that it refers to, but rather relies on the users, the project team, to label where the finishes are located. The advantage of this is that you spend less time modeling specific information to the components like say, paint finishes or wall and millwork finishes. The disadvantage of this is that the wall finish tagging is manual and possibly leading to more challenging coordination as a project evolves. This method is typically used on smaller projects with a quicker turnaround time and a lesser need for specific finish metrics information. The second way involves more intense and detailed modeling, providing finish information within each component down to each little detail. The smarter finish tag would then auto-populate when placed into the views, kind of like what happens with the ceiling tags. The advantage of this is that you would theoretically have more accurate information on wall finishes in addition to ceiling and floor finishes, which typically already auto-populate. Also, you would be able to extract more information from the model on your finishes like quantity takeoffs. The disadvantage of this is that the project would require additional coordinated modeling at a more specific and more micro level, leading to more time spent modeling. This method is typically used for larger projects where additional information is desired and more coordination is necessary to manage the project. But once again, please discuss with your team prior to getting to the model to verify which approach makes sense for the project. So looking back at the plan example on the screen, we have different types of finish tag samples. First, we have the diamond shape, which represents pretty much usually finished floors. The oval shape, which is usually placed on referring to walls. The circle, which also occasionally refers to walls. The circle, which tends to be bisected with a horizontal line in between, usually represents walls above and bases below. The trapezoid, which we usually refers to ceiling, as well as the ellipse, which occasionally means refers to the ceiling as well as ceiling heights. Some symbols may refer to the same type of surface, so be sure to discuss as a team which symbols you plan to use and be consistent throughout the project. In terms of where to locate these tags, generally, we like to place finish tags on the finish plans, pretty much referring to floors and sometimes the walls, elevations, which usually refers to the walls and the base, and reflected ceiling plans, which would be on the ceilings. Again, coordination of the team is vital. Verify which finishes you plan to note where, and do not be redundant. Kind of like the mentioning, don't be redundant. A finish should be noted in one primary location. Do not note the same finish of the same location in multiple places in the drawings, as this may lead to conflicts and confusion. The description of these tags lie in the finished materials legend, which is a next diagram there. This is usually in the front end section of the drawings, and it's where the description and other details of each finished material is described. And you can have the following noted in the legend. So you have the finish code. You have next the master specification number and title, which refers you directly to the project manual. Then you have C, which is the data categories, the general listing of those required information like manufacturer, embodied carbon, et cetera. And then you have the finish tag, which in this case is the diamond symbol. So we're looking at, say, CP01 there. And the essential characteristics, which is kind of the little X's there, is the essential information that we'll be inputting into each category. While the specifications provide full qualitative information, the legend gives an abbreviated version of the finished details, including sizing, locations, color, and so forth. It can also provide information that the authority having jurisdiction may want to have noted when reviewing the drawings for permit, like flame spread ratings and other safety standards. Note that each material listing is pre-configured by Gensler in the Revit model, allowing you to show or hide any of the data categories as needed. So now let's bring back to Salvador. We'll talk a little bit about doors.
Thank you, Brad. So now we're going to talk about door types and door tags. All projects are required to have detailed information about door types and frame types. Also, all projects are required to have included a door frame schedule, a door and frame schedule. All doors in scope should be shown on the schedule, even doors that were existing to remain. But if we're changing one small aspect of the door, if we're painting it, if we're changing part of the hardware in it, then it has to be included on the door schedule. Door and frame schedules are intended to provide the basic requirements for each opening. Door numbers, types, and hardware sets should all be indicated here. The documentation framework provides guidelines that explain how the information is to be distributed among the door type elevations, the door schedule, and the door details. Door types are intended to illustrate basic profile only. Materials, finishes, and dimensions should be represented in the door and frame schedule, not on the door type. Some examples are shown on the rectangle on the left. The Revit template has a variety of common door types that can be edited to suit each project. Now, the documentation framework also explains how to read a door type, as it will give us a better understanding of what is needed to be conveyed by these basic elevations. With regards to the door tags, these, of course, are located on the construction plans. There are two standard tags which can be applied. We typically prefer to use the larger one because it makes it easier to understand the requirements for each door, because it not only provides the door number, but also the door type and the hardware set. And thus, it minimizes the need to flip through different sheets to understand exactly what's the difference between this door and that door, for example. Next, please. So the documentation framework explains when to provide what information and at what stage. For example, at schematic design, all doors in swing direction should be located on the plans. We shouldn't have any rooms without a door, of course. The door schedule and door type schedule are not typically required in that early phase. But when we move on to design development, we should make sure that all the doors should be numbered. Typically, we'd like to number the doors with the same room number. And if one room has two different doors accessing it, then maybe we can put the suffix A or B or C on those door numbers. All doors should be numbered with door types identified, size and material of the door, and door frame identified, and any required door ratings identified and coordinated. This is all during the DD phase. Draft doors, we should draft the door schedule with access intent. And then during the CD phase, then we must have a fully coordinated door types and door schedule included with the drawing and coordinated with the specifications and egress plans. This that you see here is our standard door and frame schedule, which includes the door number, what room it leads into, the door type, the hardware set, the door dimensions and materials, the frame dimension, the frame materials, and the head, jamb, and seal details. Now, what you see there called the frame LUT key is configured project by project. So basically to make our lives easier when creating the head, jamb, and seal details on the schedule. It can be configured so if you just change the frame LUT key from 1 to 2 or 3, it'll automatically change the head, jamb, and seal detail to which it sends you to. The schedule also is very important that it supplies the assembly rating, whether it's fire, smoke, or sound transmission. And also there should be a space for remarks, which can simply be a phrase on the remarks, or you can place a sheet note there as well. And that is it for doors.
All right, thank you, Salvador. So moving along on our documentation framework, the partition systems. So there are three key parts of the partition systems. There's the details, the schedules, and the partition type modeled elements. So as you can see in the schedule, it is directly related to the wall type properties in Revit and should be controlled here in the modeled wall configuration. The partition. So in the schedule below, the 1 through 10, you can see moving left to right where the partition type, framing, details, attenuation thickness, fire rating, assembly, STC rating, and then sheet notes are all directly correlated to the wall type properties. So in controlling the wall type properties and the makeup within Revit, the wall type should auto-populate into the schedule in this fashion. As you can see, the partition type sheet, which can be found in the Southeast region template, is comprised of partition details, schedules, and tables, which all combine to help convey all the partitions for the project and how they are to be built. And then looking at the partition tag itself, the first number outside the tag is the fire rating. A second indicator, the first one in the tag, is the partition series, which is made up of 3 parts of the partition. The first part being the first layer, second part being the structure, and the third part being the outer layer. Sometimes left to right could be inside, structure, outside, or depending on what orientation the detail is showing. Letter designations here help distinguish between different partition types and compositions. The third indicator is the structural designator, where the number can be directly related to the actual size of the construction member using the provided tables inside the template. These tables are standard, but can be customized on a project per project basis based on the construction needs of the project. Obviously, with coordinating with your project team on what those indicators represent. The fourth indicator is the partition type designator and can also be customized per project needs. These customizations should be discussed with the entire team for the project for proper implementations. Some examples of the partition type designator would be partitions such as lead line partitions, vandal resistant partitions, acoustical gyp, gyp height designations, whether the gyp would go 6 inches above the ceiling, drop ceiling, or continue all the way to deck. So project teams are able to utilize this final indicator to distinguish between the different partition types within the same partition series. Revit tools and support. Well, here at Gensler, we have a support community centered around helping us all document in a consistent manner and then help our workflows to be customized. So within Revit, we have a customized toolbar, and that toolbar is filled with tools to help not only streamline the workflows, but also help standardize projects across the firm. So we have set project tools such as Sheet Note Manager, Find and Replace, and others. And we also lean on third-party software such as Ideate and Avail, which can help streamline our workflows. Avail helps us pull in project details as needed very quickly from some of the vetted design details that we have for the firm. Again, we have help within the community for Revit and for documentation framework. We have down here, there's 3 links here for you all to utilize for Gensler Know, which is the online Revit guide for standards and also has some step-by-step help on certain topics within the Revit standards or the Revit tools, so you can navigate through there. We also have BIM managers, so they're the regional experts to help guide our project teams. So we can lean on them for BIM management questions, help with our BIM execution plans, and then also within Revit when we're modeling. There's also a learn at your own pace portal, such as LinkedIn Learning, that you can lean on and use your Gensler email to log into and find topics that you are interested in that may not have been covered by your by the regional DT for training, which also can be found on the SharePoint site. So DT has taken a lot of strides recently to inform this SharePoint site with a lot of up-to-date information and links. As you can see here for the Southeast Region Design Technology Resources, we have things such as Gensler No, equipment checkouts, BIM execution plans, BIM standards, clarity, and new hire quick links, which is a really good one. So I do want to leave you with one pro tip centered around design technology, but also with dimensioning. So when dimensioning in Revit, you should not dimension to any links that you have in your project. So if you do, when the model is reopened, there will be a startup error because the association between the dimension and the link will be lost, and the dimension will need to be deleted to open the model. So we encourage all of our project teams and BIM managers to remind teams that when dimensioning, we need to dimension to native project elements versus linked project elements to avoid this documentation Revit error. Again, like I had mentioned, there's the 3 links below for the Southeast Region SharePoint resource, the Gensler No resource, and then the documentation framework link to what this entire presentation was based upon for our methodologies of dimensioning and annotation. With that, thank you very much, and we will take any questions with the remaining time.
Thank you, Sean. So just a reminder, this presentation is being recorded. The location of all the RISE presentations currently, of the recordings of all the RISE presentation currently sits the Gensler Design Labs page. That is going to be moved. The RISE recordings are going to go into a regional SharePoint site, but we will inform the region when they are moved. Regarding the questions, let's look what we have here on the chat. And Dana, thank you. You've been answering some of these already. The link for the CEU, Dana provided it on the chat. So anybody that hasn't done that, please get your CEU from there. Dana made a first comment for symbols like motion sensors and speakers. Remember, those are 2D symbols only. You may want to model these elements for RCP coordination with other devices, or make sure that your consultants are modeling them. Thank you, Dana. Amber says, I've seen some projects exclude wall finish tags on the walls of the finished floor plan. What is the Gensler standard? And Gena replied saying that she believed that if the wall is elevated, then the wall finish should be on the elevation view. If not elevated, it may be needed on the plan unless covered by a general note or other method. I agree, Dana. This goes back to not having redundant information on our drawings. And if we have an elevation where we can be more detailed as to what finish goes on what part of the wall, then that's where the finish should go. The finish tag should go, and not on the finish plan. But if the wall is not elevated, then definitely a finish plan is required. Also remember that we have general notes that can say that if a specific wall is not tagged with any finish, then the standard finish for the project is P1, RB1, etc. Ian says, pay attention to doors in curtain wall families. If the mullion profile has a recess for glass pocket, the doors will often schedule for the wrong size based on the mullion spacing, as it will size to the pocket rather than the face of the mullion. That is true. The doors in curtain walls families also, we need to make sure that we check them. Because remember, the door size is the door leaf itself, not the opening size. Catherine asks, is there a specific template to pull this door schedule from that includes the LUT key? I don't know this one. Does anybody know this one? Do we have a specific template that when you change the LUT key, it automatically pulls that?
If not, we'll research it and because I am actually curious about it too. I do more interiors projects, but I am curious about applying the LUT key method. It seems like a better streamlined, easier method to use. So
Yeah.
we'll look that up and get back with you with follow-up.
Yeah. Okay, that's all the questions we have. So if nobody else has any other questions or comments, yeah, David says it may be in the schedule already on hide columns to see. That's true. Maybe there.
To David's point, it does say in the documentation framework that column should be hidden, and it's more for internal
True.
use than it is for construction documentation.
Yeah, we don't need to show the LUT key on the PDF, if you will.
Mhm.
Maria, LUT key is basically a code that you put on the door schedule, and it'll automatically change the head detail, the jamb detail, and the sill detail for the door, so that you don't have to go door by door and say, okay, for the head, go to detail 8 of I 5.21, and for the sill, go to this one. It just makes our job a little bit easier if configured properly, of course. And yeah, thank you, Brad and Dana. LUT means lookup table. Okay. So thank you, everybody. We did it in 51 minutes, the whole thing, Sean, and you were worried, you see?
That's because you got to talk really fast, Salvador. So thank you.
Appreciate
Okay.
everybody. Thank you very much.
Thank you. Have a good afternoon, everybody.
Thanks, everyone.
Take care.